My name is Chandra Sekhar. I am school assistant mathematics in JP School, Madanpalli, Chittoor district, Andhra Pradesh. Now I want to teach the analytical geometry board. This is the analytical geometry board. From this analytical geometry board, I want to cover, for example, here this one, in a 6th class, these are all the topics. Here, number line, whole numbers, geometry, acute angle, obtuse angle, right angles. These are the concept in a 6th class I want to teach through this board and verify the results. Then I'll come to the for 7th class. These are the parallel lines, perpendicular lines, angles, vertical opposite angles and angles, transversal lines, types of the triangles and their properties. I want to explain through this board and verify the results. Then in the 8th class, that is the histogram, frequency curve and a plus b whole square, a minus b whole square. I want to explain through this diagram through this board. And in a 9th class, root 2, root 3, root 5, these are the values and Euclid postulates and transversal line problems, coordinate geometry, linear equations having two variables, the triangles and its quadrilaterals. I want to teach all the property, all these things, 6th, 7th, 8th, 9th classes using the and after completion of that one, I want to go for in a 10th and a class above. I want to teach all the concepts, for example, analytical geometry, applications of trigonometry, polynomials, statistics, quadrilaterals, quadratic equations, functions, linear equations having two variables, linear programming, tangents and sequence, geometry, similar triangles. I want to, through this board, using analytical, I want to explain all the chapters. And about 10th class also some of the concepts I want to teach through this board and verify the results what they are learned in a class. Is it correct or not? Verify through this board. Here I will arrange this analytical geometry board with using the tools as rubber bands, chains, pins, drawing pins. Here protractors, 360-degree pro circles. I will use the concepts through these materials. For example, in this one, what you learned in a textbook, the slope of the lines are like this. If the slope can be find out, the difference of y coordinates by difference of x coordinates. By this one, I want to find the slope as like this. Here, we can apply the tan theta. Then also the slopes are find the slope of the line. Here, the same concepts we learned in a textbook like this up to this position. Here I will go for tan theta, where it comes the line, where the angle it comes. Now I will move this one into the board. Here one line is arranged like this, the another line I will arrange like this. Whatever, here I want to find the slope of this line. Here I want to find the slope of this line, where this line in anti-clockwise direction it intersect find the angle through the x-axis and anti-clockwise direction. I find the value of the slope angle here like this and apply the tan theta to that angle. It comes the value of the slope. By the method of by a practical method, I verify what we learned in a textbook. By a notes we learned the same concept. I will using through this board. I will find not only this one. For example, there is a line is like this. I want to arrange the another line parallel to the previous line like this. I find the slope of this line also. Here the slopes are equal. I find. I will move the same lines through this like this. Come to this one. Here, for example, like this. I want to find the equation of the line like this. Here the coefficients, that is minus a by b. Using that formula, I find the slope in your notes or textbooks. But here the same condition I will apply here also. What the thing here you arrange in this one, the same concept, the slopes are equal here. When the slopes are equal, the lines are parallel. Here the lines are parallel, the slopes are equal. We will find the relation between the like this. Here in analytical geometry, we learned here the slopes are, the lines are equal, the lines are parallel. The same condition I will apply in a linear equation having two variables. Here the coefficients of the two lines a1 by a2 equals to b1 by b2 is not equal to c1 by c2. If this condition is satisfied with the lines, the lines are parallel and inconsistent. Here, what the relation? Here is a correlation between analytical geometry and a linear equation having two variables. These are all the concepts what we teach through this board, as here is a connection and a communication and the relation, verification and representation happens through this board. What we learned in a CCA method, all the concepts and the tools of the concept I apply in this board and verify the results through this board. For example, what you learned in analytical geometry, the distance between the 2 points using the formula as square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance between the 2 points. Here, I will arrange the same thing in a board like this. This is, for example, this is an axis, this is an x-axis. Here, this is the line. I want to find the distance between the 2 points. I find any 2 points on your board, and these 2 points I want to put it as like this. This is the scale. Using the scale, I find the distance. Like this, I want to verify the distance between the 2 points, like in this board. What we learned in a similar triangles, the construction of the similar triangles like this, 2 by 3 scale factor or 5 by 3 scale factor. For example, there is a scale factor like this, 2 by 3. Here, what we learned in a textbook, use the construction using pen, scale and compass. Here, the same concept I will arrange in this one. This is the triangle I made in this board like this. Here, the same thing I will arrange the angle as like this. Here, 2 by 3 portion, I want to make the arrangement as like this. I want to make the parallel line to this one, and the same parallel here is 1, 2, 3 parts. From this part of 2, that is, I will make the arrange rubber band like this, and I will arrange this one as a parallel to this one. Here is a triangle. This is a triangle. Previously I construct the same triangle. Here I will construct 2 by 3 portion of this one, that is the triangle as like this. Here it is the similar triangle to this one. Here, what the property here applies the similar triangles, corresponding angles are equal, the corresponding sides are in the same ratio. How can, using this protractor here and here, I want to put the angle are equal or not, and also using the scale here like this, I will find the distance. Here also I find the distance and find the ratio of the 2 points. Is it all equal or not? Through by a practical method, the construction what we learned in a class, is it correct or not? Through this board I will explain. In a geometry there is a pentagon, hexagon, heptagon, octagon, nanogon and a decagon. Here the sum of the interior angles of a pentagon is equal to 540 degrees. Number of sides, how many number of diagonals it comes, like this. All the things is happened here. Suppose for example, sum of the interior angles of hexagon is equal to 720 degrees, heptagon is equal to 900 degrees. There, here n minus 2 into 180, it comes the sum of the interior angles using the formula. In a textbook we learned here the number of diagonals we find in a polygon n into n minus 3 by 2. Here n is the number of sides. We learned in a textbook the same thing, the same formula, so we can use. Each interior angle you want to find in a textbook, what the formula we apply, n minus 2 into 180 by n. Here also we find these are the things how we come in our board as like this. Here it is a decagon, here is a nanogon, here is a pentagon, here is a hexagon. For example, I want to go for in a pentagon. Here is, I want to arrange this one as like this. Here, how much the angle is happens here also, or here, number of diagonals, 1, 2, 3, 4, 5. Here is the 5 diagonals it comes. The same formula I will apply here for this one. The same result it comes and I will verify. Here also, an example, for example, here is an hexagon. In a hexagon, this is the, I want to arrange this one as like, here is the happens is a equilateral triangle it comes. Here is it comes equilateral triangle or not, I will arrange these things same as like this. Here it comes as a 60 degrees or not in each angle of this one. I will arrange all of the things are like this. For example, go for an hexagon. Here is an hexagon, here is a decagon. Here each angle, here it is equal to 144 degrees, the sum of all interior angles. Each interior angle is equal to 144 degrees. Here, is it 144 degrees or not? I want to arrange this one as like this. Is it come or not? Here it comes as 140 here like this. I want to arrange the things as like what you learned in your textbook. By a board, I will arrange, it comes the result and verify the things what you learned in your textbook. These are the trigonometric ratios. Degrees as 5, sine, cos, tan, 5 degrees, 10 degrees, 15 degrees, 20 degrees, like this. Whatever the degrees I want to take is, for this one, sine value is how much, cos value is how much, tan value is how much. Don't use any things. I want to find the total results of these trigonometric ratios by a board. How it comes? Just come to our board. Here, I will arrange a right angle triangle as like this. Here, I will make the angle as like this. Here, this is the arrangement. This is 5 degrees, this is 10 degrees, this is 15 degrees, this is 20, 25, 20, 30, 35, like this I want to arrange. Here, I can find, I know the formula of sin theta is equal to opposite side by hypotenuse, cos theta is equal to adjacent side by hypotenuse, then the tan theta is equal to opposite side by adjacent side. Here, using the formula, for example, sin 5 degrees or sin 30 degrees, here, sin 30 degrees means it is sin we can apply opposite side by hypotenuse. Here, this is the angle. For this angle, opposite side is equal to this one. Here, using this one, I will find the measurement of an opposite angle like this, and I will find the measurement of hypotenuse like this. I want to divide that one, opposite side by hypotenuse. Then comes the result of sin 30 degrees like this. For example, you can go for cos or go for tan. The same, all the results are find through this board as like this. In a trigonometric applications, here, for example, one object, height of the one object you can find through this book, through our textbook. Like this, I want to find if tan 60 degrees, a 60 degrees value comes, find the height of any object, then tan 60 is equal to root 3 by h by 8, I want to apply, then it comes the result as like this. The same application, I want to arrange this one in a board. In this board, I want to find it like this. The same concept in a board like this, in a graph, may arrange this one. This is the concept learned in a trigonometric applications. But I will this is the problem I will take and apply this one in a similar triangles as like this by a graph of this method. Here I will arrange the 60 degrees as a point like this, and here is the point as a 60 degrees. Here I find the distance between this one and the distance between this one. Here is 8 meters, that is equal to 800 centimeters by how much it comes as a right angle triangle. Here is the base, that is equal to 2.6 centimeters. I will, after division, it comes as a 307.69 times it decreases of the same value. Then what is the height it comes? I want to multiply the number of times to the height. It comes as a 13.8. Here in a textbook or in a notes, we will find the height of an object as like this. Height of the object is 13.856 meters, but the same thing is applied in a similar triangles like this. I want to find the result as 13.846. Both they are similarly 13.8 meters. This is the connection between the applications of trigonometry and similar triangles. Let's move to another topic that is statistics. Here, in the statistics, what we learned here is an evasive curve. It is a less than cumulative frequency curve or greater than cumulative frequency curve. These are the curves or evasive curves intersect. Where it comes, they find the median of that, where it intersect. From that point, we can draw a perpendicular line to the x-axis. That is the median of the line. We learned in statistics, but come to the same concept I will arrange here. This and these the 2 points. From these 2 points, I want to find the equation as like this, using the formula as y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Using this formula, I find through these 2 points, I want to find the 2x plus 5 is minus 110 is equal to 100. And using these points, I want to find the 2x minus 5y is equal to 40. This is the concept in a this is the concept in analytical geometry. The same concept, I find the equations, then in linear equations having 2 variables, I will apply the elimination method. I find the result as the value of x is equal to 17.5. Here, in A statistics, we find the median as a 17.5. But the same concept I will connection with analytical geometry and linear equation having 2 variables. The value of the median comes as a 17.5. There is a correlation between the statistics, analytical geometry, and a linear equation having 2 variables. It is the real. Here we apply the trigonometric real life applications. What you learned in the textbook. This is the real life learning outcome. Here is, for example, it is a wall. It is the distance between the wall. Here is the steps as like this. Most preferable height of these steps are 7 inches to 4 inches. Preferable length of each steps is 12 inches to 9 inches. Preferable angle here in this one, it is a right angle triangle. Here is the angle 25 to 40 degrees. But here I will arrange, if for example the height of the wall is equal to 11 feet, here each height of the step I will take the 6 inches or 0.5 feet. Here the number of steps how many comes. Here height of the wall by height of the each steps, 22 steps I need. Here each step I will take it as 10 inches. Then I want to multiply the number of steps to the each step length of the step. Then it comes the 18.3 meters, 18.3 feet, the distance I want. Here is the real life application. What you learned in a trigonometry, I will use apply in this one. The steps, the distance between the wall to the steps where foot of the steps is like this, it comes. According to this one, I want to make the whatever the subject I will make the subject as whatever the thing. I will find the another result. Here, if I need 4 inches each step, then I know how much the distance I want. Here, each length of the steps I will put the 9 inches. How much type of height I want. This is the method I want to find this one. There is another topic, quadratic equation. In the nature of the roots, how it comes. It is a parabola. If the parabola intersects the x-axis or not intersect the x-axis, or it intersects at only one point, the nature of the roots I want to find. Here is in a parabola like this. I will arrange the parabola as a chain like this. Here it is equal to y is equal to x square. Here is, from this one, I want to find the roots of any quadratic equation like this. These are the concepts I learned. We will teach in a quadratic equation using this board and go for linear programming, having linear programming. Here is the objective function f is equal to 2x plus 3y. Here I will arrange this one as a board as like this. These are the points where the two functions are, where the two equations are intersect. That is the point. Here find the maximum value or minimum value through linear programming. The another topic is functions. Here is a functions, it is a lattice diagram. Here is the function, I want to take the x-axis, and the one set here I will take the x-axis, and what is the function here? I want to take the 2x plus 3. Here I will arrange, these are the points where it satisfies the function. Then what are the values? It comes as like this, minus 1, 1, 1, 2, 1, 5, 2, 7. These are the range of the function, 1, 5, minus 1, 7. Using this board, I will apply in the board and find the results of a range. If I move the same concept, the other concept of polynomials. Here is the polynomials. This is equal to y is equal to x square. This is the line x square minus 3x minus 4. This is the line I will arrange. This one in your board as like this. If I arrange the equation as like this, then it intersects the x-axis. Those are the zeros of the polynomials. For example, I will arrange this one as y is equal to x square, and the another line I want to pass it as like this, whereas the perpendicular line from the intersecting point, these are the values are zeros of the polynomials. It is a quadratic polynomial, cubic polynomial. Is it find the results as like this? I will move on to another topic, that is here is an analytical geometry. In this one, if the slopes are equal, here is if the slope it increases, the steepness also increases. If the slope is decreases, the steepness also it decreases. Here in a first quadrant it is like this. In the second quadrant the negative slope, the value of the absolute value of that one, it comes as a more steeper. Here a line that rises positive slope, the line with greater slope is steeper. A line that falls a negative slope, the line with greater absolute value is a steeper. This is the difference between the steep and slope.